have to take the first class online. I would have liked it to be an classroom session, but you know what is going on. So that's why we are having online. Online may not be as lively as what would have been in the classroom. So let's see, maybe after 1 or 2 weeks, everything will be back to the normal. All right. So it is more important to take care of yourself and everybody else around. So that's why. Who has joined this? 232-289. Who is this? Okay. Anyways, uh, assuming all of you got your marks in the school, how did you do in school? Anyone? Ruchir, how did it go? Both the Ruchirs.
Oh, okay.
Okay.
Yeah.
Yeah, so it's okay.
Right. So you know that the monthly test is tomorrow, and the syllabus for that is entire class 11. Fine. So uh, please take that test. That is very important. Okay. You will soon understand why I'm saying that, because one thing is that 11th is class 11th is much more trickier and difficult than the class 12th. I'm talking with respect to physics only. Okay. So you will notice that change or shift soon. So this will give you an opportunity to go back and work on your weakness, which probably you have when it comes to class 11th syllabus. Fine. But at the same time, you cannot, like while I'm teaching class 12th, you should not start learning the class 11 topic in parallel. Fine. So you will get enough time for it probably during summer vacations. Okay. Or when we are closed, like May 1 to 14 we are closed, so you can work on your weakness. Fine. So of course you will not get the entire year now, so don't expect that now you'll get a lot of time to work on class 11. So whatever time, free time you'll get where you don't have pressure of preparing class 12th, you should devote for, preparing for the 11th. Fine. Just give me 1 second. The kid is crying. I'll just. Sorry about that. So, of course, whenever some big thing happens, for example, you're done with the class 11, so that itself is, a big thing. So whenever something like this is done, we have to look back and see what which all things work and which all things did not work, so that we can correct it in the due course. Okay. So otherwise, whatever we have been doing in 11, same thing we keep on doing in 12th also, then we'll get the same result. Okay. There will not be any improvement, let me tell you that. So we need to understand what all the mistakes or what are the learnings we had from the class 11th. Fine. So, so any one of you want to speak about what kind of mistakes or what all things did not work? It could be from either side. Maybe what we were doing, you wanted it to be in a different way. So whatever you may feel like, please speak up. You have anything to say, Dhruv?
No, sir.
No. So everything went ekdam 100% perfect, huh?
No, so like at the start of the year, I didn't actually study that much, but then this year I have a plan. So, like the moment we do something in school, I'll try and finish at C. Varma.
Okay.
And then that way, when we do it in Centum, if it's after school, I'd be more prepared for the class. And then, yeah.
All right. So one thing, see, I had class 12th in Rajaji Nagar also yesterday. So I was taking a class there also, and it was again a big batch of around 30 kids. So a few things that came up there, which everybody had accepted, and I think most of you might have done the same thing, was they were giving the UTs much more attention than UT over, came-on test. So UT versus came-on test. When it comes to comparing, what is came-on test? It's a monthly test. So like one monthly test you're taking on Saturday, that is tomorrow itself. Fine. So when it comes to UTs, the kind of attention you give to prepare for UT is probably 2 to 3 days. Okay. But when it comes to came-on test, you just study for one day. Fine. So that doesn't work, and you have seen it over the entire year that that kind of effort will not fetch you anything. Okay. So one more thing you might have understood, that it is very easy to score in the school exams, the knowledge based paper. You have to just remember a lot of knowledge, and you go out there and you start doing well in the UTs. Okay. Whereas it is very difficult to do well or improve your marks in the K-Mon test like scenario. Fine. So if you have not made a consistent effort right from the day one, then there is a high chance that you may falter there. Fine. And at the end of the class 12th, you're going to write a test which is similar to the monthly test that we are conducting. Fine. So most of you are planning to stay back in India. So you will be facing an exam like NEET or JEE Mains or JEE Advanced or BitSat or CET, any kind of those exams. Everything will be like came-on test. Okay. So this is a high time to wake up and start giving the due importance to the came-on test. Fine. And the preparation of the came-on test, in fact, should be done right after the previous came-on test. When I say preparation of came-on test, it doesn't mean that you start waking up and don't sleep and day in day out you just prepare for came-on test. Preparation for came-on test simply involves attempting your assignments uh, when it is due. Okay. So if I give you one assignment today, you should be able to do it within a week's time and not just pile it up. Fine. So just do the assignments and you will be fine with it. Okay. And one more thing that came up, you can correct me if I am wrong, was many students in Rajaji Nagar told me that, sir, the assignments were a little bit difficult than what it should be during the first attempt. Is it true? All of you agree with that? Akshit, what do you think?
No, sir, you gave us different levels of assignments, right? Mains and advanced. So if you attempt the mains questions and take some time for the advanced, I think that worked for me.
Okay. All right. So what, but then I have, maybe some of you are not speaking because of whatever the reason is. So what we have done this time round is that we are going to give you 4 levels of assignments. Okay. So we are going to give you CT level assignment that should be done, um, you know, a prior, like it should be done. Okay. You can't escape it. Then there has to be a J mains level assignment, which you can also say is a neat level assignment. Okay. And then we have KVPY and advanced level assignments. Fine. So KVPY level, when I say, it is not a different level, but KVPY questions are different. They are more theoretical and conceptual. They may expect you to think some different way. So that's how the different kind of questions will be there. So there are 4 levels of assignment, and the most important thing, this time the assignment will be timed. Okay. the assignments will be online and it will be timed. So what does it mean? It means that if I'm giving you a CT level assignment, there might be 60 questions of physics. Okay, you have to attempt probably in 1 hour 30 minutes. All right. So usually what happens is that nowadays the distraction is so much. You have laptop, then YouTube, Twitter, then whatnot. So many social websites are there. So when you sit to do the assignment, same 60 questions, if I don't time it, you will not take 1 hour 30 minutes. You will probably take 10 hours 30 minutes. Okay. So or 5 or 30 minutes, you will not realize where your time go. So that is the reason why I wanted it to be a timed affair, so that when you sit to do or attempt the questions, there's a timer running in, which I will probably increase it a bit. Probably 1 hour 30 minutes may not be first attempt. I could make it 2 hours, but then at least for 2 hours you have nothing else to do. Okay, so that way you could finish your assignment, and there's a timer running, so you'll take it much more seriously. Okay, and immediately after assignment is over, the solutions will be presented to you. Once you click the submit button, you'll get your score, and all kinds of analysis you'll get along with whatever solutions are there, so you could see everything fine and see what went wrong and so on and so forth. So similarly, this is CT level assignment, probably 60 questions of mains level. I'll be giving you probably around 3 hours to just attempt 60 questions. So like that, it will be a timely thing. And at the same time, whatever you do, everything will get recorded online. So suppose after 5 months, you want to see what all questions you did wrong or attempt wrong, what went wrong. So everything gets recorded. You can see your profile and see all those things. So it will be nice. Ruchir Singh, you wanted to speak something?
So are these assignments going to be separate subjects, or is it going to be like a test of all subjects together?
Separate topic itself. For example, I'm done with electrostatics. Okay, suppose I'm done with the electrostatics. After the chapter, there will be 4 level of assignments that you have to finish. Okay, so there will be CT level as electrostatics assignment, mains level electrostatic assignment, and so on. But of course, it will not be topic wise assignments. Okay, topic wise assignment I'll keep on giving you independently after the class. Okay, but once the chapter is over, you have to do these assignments as test. Okay, so that way it will be helpful. Rahul, you wanted to say something? Raise your hand, Rahul. Okay. Anyways, so this is what we are planning to have. And apart from all of this, we are going to give you logins in which everything will be recorded. So all the chapters, what we have done, in fact, we have already put it in our YouTube channel. Apart from that, what we have done, we have properly segregated it. We have divided entire chapter in maybe 15-20 minutes videos. So on electrostatics itself, you will find around 30 to 40 videos of 15 minutes each. So if you want to revisit those topics as a video lecture, you can go against your login, look at those videos at your own pace, and you could pause or play, and you can watch those, all of those things fine. So this is what the major change that we have proposed. Depending on whichever students I have spoken to, we have come up with these changes. So hope these will do some good. And with respect to organizing your time, okay, these things whatever I have done will not make you sit in a chair and start working hard, because that is within you. All right, that nobody can do anything. But what I'm ensuring is that if you are ready to invest your time, then all of these things are there in a structured manner, and it will help you to do everything very efficiently. Fine. So all of these things will be given to you maybe in couple of days time. Fine. So this is what I wanted to highlight. This is based on whatever we have learned uh, from class 11th. All right. So anybody else has any comments to make or anything with respect to class 11th? Okay. So we are good to go. Okay. All right. Now, let us start the class 12th physics. Fine. So all of you please write. Treat these online sessions as if the class is running. Okay. Don't just sit with popcorn and watch it like a movie. Have a copy and pen and write everything that is there on your board. Fine. So class 12th physics. All right. So in class 11th, the central theme of the all the topics was study of mass, right? So we have started with kinematics of the particle or the mass. Then we have learned about laws that governs the motion of the mass. Then we had rigid body dynamics of a mass. Then properties of masses, mechanical properties of solid and mechanical properties of liquid. Both are mass. And then we have thermal properties of the solids or gas, thermal properties of matter. So like that, we have almost every chapter talked about mass. Fine. Just that at the end, there was a chapter called waves, which did not talk about mass, but largely entire class 11th was focused on mass only. Fine. In class 12th, our focus is now shifted to study of charge. Fine. So class 12 center line is study of charge. All right. Now, when it comes to study of charge, it is observed that the charge at rest behaves differently from when charge is in motion. Fine. So that is the reason why we are going to study charge in a different way. We are going to first, class 12, the first chapter is that deals with charges at rest. Please write down. See, these organization is very important because what will happen is that soon lot of information will be dumped on your head, and if you don't organize the day one of the lecture that these are the buckets in which the information will go, then it becomes very problematic. So right from the day one, we should know what we are studying and how the entire curriculum or the syllabus is organized, so that whatever information comes in, we know which basket or which place I have to put that. Fine. So the first important topic in class 12th is charges at rest. Has the class 12 physics started in your school? Has it started?
Yes, sir.
Yes, sir.
I hope they haven't went ahead very fast. And what is going on like in your school? Are they closed till 11th of May?
Yes, sir.
Yes, sir. Yes, sir.
Did you get any official notification?
Yes, sir.
Yeah.
The same message.
Oh, so that is blessing in disguise. Actually, you have a lot of time now.
Yeah.
So
So
please.
will every center class be online now? Or
What,
is
what?
it just this class? Will every class be online now, or is it just this class?
See, we are taking online class because of the panic that is there in the city and because of some government notification. All right. So as soon as the panic settles or the government stops sending the panic messages, we're going to be back on the classroom setup. Fine. Because I personally don't like the online setup, and none of us, in fact, likes it. Okay. Because online setup limits the kind of interaction that is there. But of course, it limits the the interaction among you guys also. So that way, probably we'll move a little faster. But having said that, classroom is anyway better. So probably in couple of weeks time, 1 or 2 weeks, everything will be settled and we'll be back to normal. Tell me.
Did the government like actually send a like notification separately for coaching classes, or is it just like in general they like don't gather?
It is in general. They don't send for the coaching classes because it's a private organization. Okay.
Okay.
And many parents as such have requested us to take online classes. And
Okay.
one more thing, your school got over at 12:30 and
Yeah,
the scheduled time was 4:30. So a lot of things were there. So I don't want to unnecessarily push for the offline. Okay.
Yeah. Okay, sir.
Sir,
Okay.
apparently
Anybody
they
else?
raided NPS Kormangla. Like, that's what some people are saying.
What?
Apparently, like some government officials went to NPS Kormangla to see whether the kids were actually there, and they said only kids that are writing exams can be in school. The rest of them have to be at home. And then some people are saying that's why our school also just sent us before the government dudes come.
The government had sent notification yesterday itself. Probably there was a misinterpretation of the notification. They have told only exams of 10th and 12th students who are writing should be there. What probably school understood, the students who are going to 10th and 12th can come. Okay. But the message was the students who are currently writing 12th exam or the 10th exam, they should be there in the school, not the students who are going to the 10th and 12th. But anyways, coming back to this, that discussion will never end. So the first section, okay, and probably 20% of your curriculum is charges at rest. Fine. And charges at rest formally is known as electrostatics. I know a few new students have joined, and this is not a correct medium to get introduced to each other. And so I'll wait for a classroom setup, and then we could better get introduced and everybody will know each other better. Okay. So sorry for that. We could not introduce. All right. So electrostatics is the formal name. And since electrostatics is huge, so that is why we have divided into electrostatics 1 and electrostatics 2. Okay. And these two topics, which constitutes 15 to 20%, they are considered to be the most difficult topics of class 12th. All right. And let me tell you that they are extremely simple when you compare it with the mechanics of class 11th. Fine. So we are dealing with a very simple syllabus. So electrostatics is a study of charge at rest. At the same time, we are going to study the charge the first time. Like the way we started the class 11th curriculum, and the first chapter was measurements. Second chapter was kinematics. So in class 11th, we have assumed that you don't know anything, even though you might have studied about laws of motion and so on and so forth. We started from scratch. Similarly, in class 12th, even though you know what is charge, so you need to unlearn everything, whatever you know, and learn everything from the scratch. Fine. So in this chapter, you're going to learn about a different kind of force which is between the two charges. Fine. And you know that like charges repel and unlike will attract. So we are going to quantify that charge, or quantify that force. Okay. How much is the force between the two charges? And you remember gravitation chapter? So gravitation chapter we have studied in much greater detail. But in textbook, it was just introduction of force and satellites. Fine. So similarly in electrostatics, if you have learned the gravitation with us properly, you'll realize electrostatics is extremely similar to the gravitation. Because in gravitation, G m1 m2 by r square was the gravitational force. Here, K q1 q2 by r square is the electrostatics force. Okay. So the formula looks very similar. So you have learned about the gravitation field in gravitation chapter. We are going to learn electrostatics field in this chapter. Fine. Then we have learned about the gravitational potential in gravitation chapter. Here we're going to learn electrostatic potential. Okay. Everything is extremely similar to each other. Just one variation is there. The gravitational force is always attractive. Electrostatic force can be repulsive also. Fine. So all of these things are there in electrostatics 1 and 2. And of course, there are many other finer details. So electrostatic 1 and 2, we introduce a force, then field of that force, potential of that force, and potential energy of that force. Fine. And once these basics are covered, then of course, Newton laws of motion, force is equal to mass times acceleration is valid here also. Work energy theorem that you have learned is valid here also. So once I tell you how much is the force, you can apply Newton's second law. So there are a lot of numericals that are that mixes the concept of electrostatics with laws of motion and work per energy. Fine. So there is like n number of questions that just mix the two concepts. And then you have some devices. For example, capacitor is one device to store the charge. So it is extremely difficult to store a charge. You will hardly see an isolated charge anywhere. So that is why talking about a device to store a charge is very important. So we are going to discuss that. And then there are a few more devices that are removed from your curriculum that, for example, Venn diagram generator. But even though it is removed, we are going to discuss that as well. So this is electrostatics 1 and electrostatics 2, charges at rest. Fine. Then the next section of your curriculum talks about charges in uniform motion. Give me some example here. What's the best example of charges in uniform motion? All of you are on mute if somebody is speaking.
So electrons in a circuit.
Electricity.
Yeah.
Okay. So that's the reason why the next topic after electrostatics 1 and 2, we have current electricity. Okay. This is, of course, it is very similar to whatever you have learned in class 10th. There will be Ohm's law, then there will be resistances in series, parallel, and apart from that, we are going to discuss few instruments also. Okay, there will be Wheatstone bridge, there will be ways to calculate the resistances, ways to calculate the EMF of a battery, ways to calculate the internal resistance of the battery. So there are some instruments to do that. We're going to study those as well. Fine. So this chapter is very simple, okay, and it is there because we have to study the charge. All right. And after current electricity, in class 10th, you might have learned that current can produce the magnetism, right? So that is the reason why you have the 4th chapter as, please write down, moving charges and magnetism. Okay, and this is the biggest chapter of the entire 12th curriculum. All right, it's a biggest chapter, biggest topic, and good thing is it's a simple chapter. Fine. So moving charge and magnetism, will talk about the magnetic field that gets generated because of moving charge. Okay, so it's like talking about what is the effect of moving charge. And at the same time, one section of chapter also talks about how the external magnetic field creates force on the moving charge. So what moving charges does and what is done on the moving charge. So both ways this chapter discusses, and then of course there will be some instruments that we are talking in this chapter. Like every other chapter in the class 12 will end in some sort of instruments. Electrostatic 1 will end with introduction of 1 or 2 instruments. Electrostatic 2 will introduce couple of instruments. Current electricity will introduce. Moving charge and magnetism will also introduce. Okay, so all these chapter discuss few instruments, and then you have a chapter, magnetism and matter. What do you think this chapter is about? This chapter, what do you think this is about?
Effect of magnets on different substances.
Yeah,
Like
it is.
daily objects or something. Magnetism in daily life, maybe, sort of.
So it talks about like what most of you have said. It talks about how the matter contains the magnetism and how it comes, and how to measure the amount of magnetic field due to the matter, and so on and so forth. So of course, when magnetism was discovered, it nobody was aware of that moving charges can create magnetism. When thousands of years back magnetism was discovered, the first time they discovered magnetism was when it was there in lodestone, which found in the place called Magnesia. Okay, so that is the first time people discovered the magnetic material. People used to think that it has some god-like property. They started worshipping it. Then many ladies started wearing jewelry made up of magnetic material, but then soon everybody realized that it is there abundantly present everywhere. So all those, the abundance is there, so all the exclusivity is gone, and then it was treated just like another object. But then of course there are a lot of other useful aspects to the magnetism that we're going to discuss when we talk about magnetism. So 2 chapters on electrostatics, 2 chapters on magnetism, and 1 chapter that connects these two. It is electromagnetic induction. It's called EMI. Okay, so this is a very important chapter. It's a link between electrostatics and magnetism. So what it says that you can generate magnetic field from electric field and vice versa. Fine. So if you have electric field, you can generate magnetic field. If you have magnetic field, you can generate electric field. So it's a very, very important, discovery. Just to tell you, it is very easy to create magnetic field. Okay. For example, if you have magnetic field due to a circular wire, current carrying wire, as B naught at the center, B is a magnetic field. If you want to double the magnetic field, all you have to do is just double the number of turns here. Take 2 turns of current. Magnetic field will be double. So it is so easy. So if you want to make it 1000 times, take 1000 turns. All right. So, but then our electrical instruments work on potential difference and electric field. Okay. But that is not very easy to generate directly. So what people do is that they generate high magnetic field, and from that high magnetic field, they convert it into electric field. And that is what the AC generator or direct current generator does, which we have already studied in class 10th. Fine. So this is what the electrostatic and magnetism is about. And combining all these chapters, which you could see on your screen, you can easily say that all of this constitutes more than 55 to 60%. So almost all topics are covered. Okay, this is your more or less the book 1. Fine. And then there is another chapter which is little disjoint, so that's why I'm writing it separately. It is alternating current. Okay, this is again a bigger chapter which talks about how alternating current behaves. Fine. So this is with respect to the study of charges at rest and charges in motion. Fine. Then there is another scenario, by the way, which talks about charges in accelerated motion. Sorry. So it is found out that when charges accelerate, they will generate EM wave. So we are going to discuss the effect of the accelerated charges as a chapter name called EM wave. Okay, there is another chapter in sequence to EM wave, which is communication system. So communication system is a very small topic. Even wave is also a very small topic. Okay, but since it is there, I am writing it down. All right. So these are the topics which talks about all kinds of properties of charges, and after this, the study of charge is over. Okay. But then our curriculum is not finished. We are going to then move on to a very different world altogether, which talks about modern physics. We usually discuss about quantum physics. So quantum physics is modern physics only. So modern physics is now officially a part of class 12th now, so we can now study it properly. And the best part about modern physics, the best part is that it is there in chemistry also. So if you study modern physics, it is going to benefit you not only in physics, but also in chemistry. Okay, so the kind of chapters that I'm talking about, you might have done atomic structure in 11th only, right? It was, right? So the similar kind of chapter is there in physics now. The name is atoms. Okay, so even though its name is atoms, we are going to discuss mostly about the electron of hydrogen atom. So we are going to discuss about the Bohr's model, Lyman series, Balmer, Fund series, all that you have done already. Okay, so modern physics will give you a lot of benefits. Not only it is there in the chemistry also, at the same time, it is a very, very simple topic. All right. But people ignore it. The reason is because it comes at the end. So at the end, people become very, they tend to ignore things. So, you should not do the mistake and take modern physics very, very seriously. It is giving you free marks. All right. So it's like inorganic chemistry of physics. So atoms, then you have nuclei. So nuclei, in atoms, we have discussed about the electron or hydrogen atoms electron or hydrogen-like atoms electron, how it behaves, Bohr's model and things like. In nuclei, we are going to discuss how nucleus behaves. Okay, we are going to discuss about spontaneous nuclear reactions that happens in the form of radioactivity. Okay, and then we are going to discuss about nuclear reactions. Okay, so in chemical reactions, electrons take part. Okay, so all the chemical reactions, chemistry is taking care of. We are not discussing any chemical reactions here. When I say nuclear reactions, the nucleus takes part. So when nucleus takes part, the protons and neutrons are involved in the reactions, and the tremendous amount of energy is released when an exothermic nuclear reaction happens. So that is what we're going to discuss in the nuclei chapter. Okay. Then we have a topic, dual nature of radiation and matter. So this chapter tells you that every object on the earth has two natures. One is the wave nature and other is particle nature. Okay, so it will discuss the particle nature of radiation and the wave nature of matter. Okay, so you might have heard about the photons in class 11th, right, in chemistry. So photons are the energy packets. So basically you're saying that the light is a collection of particles when you say that it is photon. Okay, so you're treating light as if it is a particle, not a wave. So same kind of fundamental discussion will happen in this chapter as well. Then there is one more chapter, name is Semiconductors. Semiconductors is a very theoretical chapter. It will just dump you with a lot of information. You just have to remember and produce it in the exam. Okay, so I'm putting it very crudely, and that's how it is. All right. So modern physics is around 20 to 25% of the curriculum. Again, it's like, you know, somebody is giving you free marks, so don't miss that. Then you have the last section is optics. I'm not going in sequence, but this is how it should be studied. Optics will discuss ray optics and wave optics. Optics is a study of light. The reason we are studying light independently and we are giving so much importance to the study of light is because light makes us see anything. Okay, so if we don't know how light will behave, every time we observe something, it may not be correct. For example, when you look at the sky and you see at a particular corner there is a star, so if you're not aware that that your resolution is very less, you'll never understand that at the same spot there could be 1,000 stars. So that is why once you know how light behaves, you'll build telescope or microscope and see all kinds of bacteria or virus, study them. Then you can see the objects which are very far and study them. So all those, all these instruments are possible only when you know how light behaves. If you don't know how anything behaves, then you can't control and make an instruments out of it. Okay. So it is found out that light will, given one scenario, light will behave like a ray, and given another scenario, light behaves like a wave. So it's like when light is happy, it behaves like a ray, and when it is sad, it behaves like a wave. So depending on scenario, the behavior changes. Okay. So optics constitutes around 15%. Okay. So don't start adding up and say that 100% is not over. So it is all rough, this thing. And this is what your entire curriculum of class 12th is. Okay. Electrostatics 1 and 2, slightly difficult, but much more easier than your mechanics. Okay. And everything else is even more simpler than electrostatics 1 and 2. So we are dealing with a very, very simple curriculum. And I have put a deadline of finishing this curriculum by October 1st or 2nd week. Okay, so we will be over with the physics class 12th by October 1st or 2nd week. And then we are going to revisit the class 11th topics by the time maths and chemistry will catch up. And once they catch up, then mid of November or the first week of November itself, we are going to start problem practice, only problem practice, wherein we are going to meet daily and solve 3 to 4 hours of problems, because the target is your first exam, which happens in the month of January. So January JEE Mains is your best bet. So if you are thinking that you will target April JEE Mains and that is your best chance, change your mind, because that will never happen. Okay. So January JEE Mains is when everybody is lesser prepared, so are you. But then most of you are in the equal footings. But then when you will be busy preparing for board exam, many are not busy with the board exam. So if you want to compete at the level playing field, January JEE Mains is an opportunity. So now that JEE Mains happens in January, it is a good thing for us. Fine. Any doubts or any comments or anything from anyone?
So just like one small thing I thought I'd ask at the end of class, like I wasn't there in 11th, so what do you recommend like I do for the 11th grade portions, like for more practice? Like should I get the modules as such for all the subjects which like I've seen in school, like a lot of people here are in school, like I go to MPS SSR only, so should I get those modules and just practice regularly from them, or should I do anything extra?
Okay, so have you been to any classes as such beyond school?
No, like for JEE preparation and such, like not as such. Like I was doing home tuitions only, so in that, like very flex. Sometimes the teachers used to give like few mains level questions maybe, but not like regular practice as such.
So you could do one thing. You could meet me independently, or after the class we can have a discussion, because yours is a very specific scenario. So we have to discuss it in detail. But
Okay.
just again, I'll reiterate what I have told earlier was, don't start class 11th while I am teaching class 12th, because then
Okay.
neither class 12th will be done properly nor class 11th will be done properly. Okay.
Okay.
So the ideal time will be when the oh, so summer vacation have started. So I was about to say when summer vacation starts.
Okay.
So the ideal time will be, yeah, when summer vacation start, which have already started. So yes, we can probably devote some part of the day studying for class 11. So you could get in touch with me. Okay, don't just
Okay.
randomly start doing something
Yeah.
without supervision.
Yeah.
And this is one thing I wanted to say. And then May 1 to May 14, center will be closed. So those 14 days are your, this is what your opportunity is to revisit. And one more thing, October 1st week, class 12th syllabus is going to get over. So from that point onwards, a lot of time is there to revisit again the class 11. Okay.
Okay. Yeah,
But
no, my mom wanted to meet anyway, so I'll probably
yeah,
come in the next 2-3 days maybe. I'll like
sure,
tell her to ask, so
sure.
I'll come.
And yeah, so what I was saying was that the best part is that syllabus will get over by October 1st or 2nd week. So a lot of time is there. But the caveat is that all of you have to move with me. For example, I'm doing electrostatics right now. You should not be like, okay, fine, let the work accumulate, and later on when the time will come, I'll do the homework and do everything. So by when the October will come, you'll be like, okay, fine, I have not done the 12th properly, so I have to do that first. That should not happen. Okay, so if you think that your class 11th was not that well prepared, I would suggest you prepare your class 12th very, very seriously, so that class 11th, when the time comes, you have a lot of time, and in your mind it will not play that I have not done 12th also properly. Okay, so that is very, very important. Anybody else? Anything else? Okay, Kritika wants to say something. No. Fine. So I assume that all of you have understood. Vikas, you're saying something? Fine. Anyways, so I assume that all of you have understood the plan. Okay. See, I don't want to create a lot of pressure. Fine. So the thing is that if we do everything at the end, the pressure will become very high. Okay. So there is a work. Okay. There is these set of chapters which are there in front of your screen. This is your work. Okay. So if you spread this work uniformly and you move with the class, you finish the assignments in time, you will be lot more relaxed when the time comes. Okay, so take these things seriously. And what I am saying is an experience of 10 to 12 years. Every year I see the students passing out and I understand what kind of mistakes they have done. And they also tell me all sorts of things what went wrong, but then they can't correct it, right? Okay, fine, you made the error, but then you'll not get an opportunity to correct that error. Fine. So don't make a mistake by ignoring whatever I'm saying. All right, so this is the
So, Akhil sir told us that we'll have 2 chemistry classes every week. Is that going to happen?
See, the plan is that to give the chemistry more attention, definitely. Okay. Now, it will not be a scheduled thing where every week 2 classes are happening like that. But then, yes, we are planning to give more attention to chemistry because of its first, the vastness. And the second point about chemistry is that it's a scoring subject. You like it or not, this is the fact. You can score 100% in chemistry if you take it seriously. Okay, if you give a lot of time, you will score. Same thing I can't say about maths and physics. So that is the reason why we at Centum Academy are also taking chemistry very seriously, because ultimately we have to fall in love with marks, not a subject. And that is the reality. So we are going to give special attention to chemistry, but every week may not be possible. But yes, most of the time there will be problem practice, and we are planning to have something like that. Yes. Okay.
Okay, sir.
Anything else? So we have spent 1 hour in introduction of 12th and what went wrong in 11th. Anyways, so let us start the today's chapter. Write down. The first chapter is electric charges and fields. Okay, so this is your first chapter. This is also referred in many textbooks as Electrostatics 1. Okay, and many a times in textbook, they don't even split the electrostatics in 2 chapters. They just write electrostatics, and both your chapters 1 or 2, first, second chapter, both are there in the single chapter itself. So when you refer to some book, don't get confused. Okay. Fine. So we are going to discuss this chapter with, the discovery of electrons and discovery of charge and so on and so forth. So like every time we are going to start with the basics. So please pay attention to each and everything that we discuss here. Fine. So what do you think the experience of charge would have been the first time charge was experienced? By the way, have you experienced a charge ever?
Sir, static electricity.
I was just gonna say.
Static
No,
electricity.
I've experienced current.
Current. So the shock, electric
Yeah.
shock.
Sir.
I've experienced
Yeah.
shock once, like really long back then.
So that's like the
Sometimes when you're combing your hair, you can hear the charge. Like I can
Yeah,
hear
dry
something.
hair, dry
yeah,
hair.
dry
Yeah.
hair. So
And like if you stick your finger in a plug point, then like your entire
Yeah.
hand jerks.
yeah. So that don't do all that.
Young.
You may have to pay heavy price sometime. One of my dad's friend was working in some factory. He got a shock, and that electric shock has affected the functioning of heart also. So he has become a heart patient after that. So it affects big time. Okay, but anyways, so when it comes to experiencing the charge, we have all experienced in one way or other And we have all played with that simple thing. When we were kid, we used to, with the plastic scale, we all have rubbed our hair and we try to pick up the, small pieces of the paper. And even though the paper is experiencing gravitational force downwards, it moves up. So, which is mysterious, because actually it should not move up. Gravitational force is down. So there has to be some other force that is there on the scale which is pulling the paper up. Okay, but here is a small question to all of you. We have discussed the like charges repel and unlike charges will attract. So how come a scale which is charged, let's say scale is negatively charged, how come it is able to move the neutral paper? Paper is neutral. So how the paper is getting attracted?
Like the charge is induced into it, right? Like when you bring close to it.
So the paper is made up of atoms, and inside atoms there are electrons. So electrons inside the paper will go further away, because of which positive charge is there. So positive and negative charge become close to each other. So attraction becomes more than the repulsion.
So it'll form something like a dipole. One side positive.
Dipole induced dipole. That's concerned.
Yeah, so all those things anyway we are going to discuss. So it is not that Ruchir wanted to say something.
So why is it small paper, sir?
Why is what?
Why do we take a small piece of paper? Like, what's the significance of small?
Because the charge on the scale is very less. Maybe 2-3 electrons are extra. It can't pull a heavy mass. Okay, so even though induced charges will be there, it can't pull the heavy mass. That's the reason why. Okay, but anyways, all these induced charges and all that we're going to discuss. So the point was, the charges can not only attract the opposite charges, it also attracts the neutral objects. Okay, so we have experienced the charge, and then when you wear a jacket, you hear those tickling sounds. That is the transfer of electron from your body to the jacket, or jacket to your body. So that's a small, let's say, lightning that is happening. And then when you put the blanket, okay, when you're about to sleep, when you put the blanket, you again hear some small tickling sounds. All those are nothing but transfer of electrons from one object to the other. In fact, in a dark room, when you put the blanket, you can actually see the sparks also. So when electron moves from one place to other. Okay, the great example is thunderstorm. So lightning that happens. So that is all, the charges only that are moving from cloud to the earth. Okay, so all these movements are governed by one simple nature of the charge. Please write down: charges by nature charges want to get neutralized. Okay, this is the behavior of charge. This is what charge wants to do. Okay, it's like the masses have inertia, charges have this property. Because of this property only, unlike charges will attract. Okay, so charges will try to get neutralized. And when nobody knew about the fact that there exist electrons or protons or neutrons, during those time also people knew that there exists something called charge. Okay, in fact they used to think that charges are nothing but fluid. Okay, so long back the first people used to think that a positive charge object is filled with fire and negative charge is filled with water. This is what people used to think. And when fire meets the water, it gets neutralized. So when plus meets minus, it gets neutralized. So this is what people used to think. In fact, the first periodic table that was made was based on these 5 elements only. People say Panch Tattva, right? That fire, water, earth, air, these are the 5 basic elements. It was the first periodic table, and they used to think that everything is made up of fire and water. And they have, they have started putting it so fundamentally that people used to say that if somebody gets angry, most of the time, a lot of fire in it. And then if somebody is very docile, so people used to say that it has a lot of a lot of water in it. So that's how philosophy has also grown. But then, of course, it was not fire and water. Okay. So the experiment that led to the discovery of the charges was what experiment we have discussed just now, where rubbing of the plastic creates a charge. So people have understood, that if they rub a glass rod, so if you rub a glass rod with wool, it will acquire positive charge. Sorry, positive charge will come later on. It will acquire one kind of charge. Okay, it will acquire first kind of charge. Okay, and if you rub another glass rod with the wool, this will have the same kind of charge. Okay, and when you bring same kinds of charge close to each other, they start repelling. So this is what was experienced. So this is the beginning of the fundamental that like charges will repel each other. Okay, so without knowing electron proton exist, people have understood that same kind of charges will repel. So using this experiment. Okay, but then when they rub a plastic rod, it's a plastic rod, it acquires second kind of charge. The reason why it is called second kind, because when you bring this plastic rod with the first kind of charge, they start attracting. So the behavior is changed now. Okay, so that's the reason why it is called the second kind. And a lot of experiments were conducted every time this is what was happening. So people have understood only 2 kinds of charges exist. Okay, and if you touch the plastic rod with the charged glass rod, the property of their attracting goes down drastically. In fact, at times it becomes 0. Okay, so people have understood that if you touch positive charge to negative charge, it's like things get neutral or nothing is remaining, or people say discharged. Okay, so that understanding of something is there at one place and something else is there, they both meet and they both vanish each other. Okay, so on similar concept, matter and antimatter is also have been thought of. But then still coming back to this, so this is what is experience, and that's how people have named it fire and water. Okay, but then this is not a proper naming. So Benjamin Franklin, Benjamin Franklin, you know it?
So he flew a kite in that thunderstorm or something.
No, that's not the only thing he did. The most important thing is what? Tell me, what is the most important thing? Have you seen dollar bill?
Yeah.
On the dollar bill, there is Benjamin Franklin. Okay, so
$100 bill.
What?
$100 bill, the highest bill.
Yeah. So Benjamin Franklin, by profession, was a banker. Okay, so he was also fond of science. So like what Param was saying, he used to do some experiments with a kite and all. He's done those experiments, and but at the same time he was banker also. His main profession was banking. So when you are in a banking sector, or when you're too fond of your money, you keep a watch on how much money is coming in and how much is going out. Okay, so debit and credit. So when money comes in, usually you associate it with a positive sign, and money that goes out is negative. Why you do that? So that you add it properly. Suppose 100 rupee comes in plus 100, 20 rupees goes out minus 20. So when you add it up, it becomes 80. So plus and minus sign gets associated with credit and debit. And that's how Benjamin Franklin, who was a banker, coined this terminology of, keeping one charge as positive charge and other charge as negative charge, rather than fire and water. So this is the beginning of how positive and negative charge were named. But still, nobody knew that there is electron, proton, or neutron. It turns out that what Benjamin Franklin have thought of as negative charge has excess of electrons. So electron automatically becomes a negative charge. Okay. So this is just a naming of, this is just the naming of the charged particles. And in reality, then later on, all these atomic theories have come in, and the biggest, the most important discovery, Richard Feynman also said that if entire this Earth is all the humans are gone, only one concept, if you have to leave to the future generation, that will be the atomic theory, that everything is made up of atoms. So that is the importance of atomic theory. And once it was clear that all the matter, whatever it is in entire universe, is made up of atom, and then the discovery of electron, proton, and neutron have come in. Okay, so basically charge exists everywhere. Charge exists in all mass. So if there is an atom, atom will have electrons, atom will have protons, and it will have neutrons. These are the fundamental particles. Why we are calling it fundamental? Because the assumption is you cannot divide electron, proton, or neutron. Even though it is now found out that you can further divide electron and proton into 1/3 of electron or 2/3 of electron, but we, for the sake of this class 12th syllabus, we are going to assume that they are indivisible. Okay, so indivisible particles we are going to assume. Understood? So now, if this is the case and there is no other lesser particle than electron, so what is the least charge? Least charge should be equal to what? Least amount of charge. Least amount of charge will be that of electron. Yes or no? It will be that of electron, because that is the smallest charge or smallest particle that exists. Fine, which is indivisible. So least amount of charge is that of the electron. And if atom is neutral, then equal amount of positive charge should be there and equal amount of negative charge should be there. Okay, later on it was found out that since number of electrons are equal to number of protons, that means charge of an electron is equal to charge of a proton, because atom is neutral. So number of particles, fundamental particles, should be same when it comes to electrons and proton. Neutron could be anything. There is there is no such law as such, but then yeah, it causes instability of the nucleus, but that will deal later on. Okay, so all of this is very clear, right? In fact, it's simple as well, so we don't need to worry too much. And the SI unit of charge, please write down. You know what is SI unit of charge? Coulomb. Coulomb. It is Coulomb. Okay. And how much is the charge of one electron?
1.6 10 to the power 9 minus 19.
Minus 19 Coulomb.
Sir, what is the dimensional thing for 1 Coulomb?
Dimensional
into time.
What?
See, the thing is that, see, I was coming to that only little bit later, but since you have asked, we have, this is even though the fundamental unit, Coulomb is even though the fundamental unit, the basic unit is current. This is not part of 7 SI units. So the current is the basic unit, which is dq by dt. So the dimension of charge is ampere into time. This is the dimension of charge.
Okay.
Okay. So ideally, charge should be the basic unit, but they have kept current as a basic unit. The reason is that it is nobody have till now found out a way to measure the charge accurately. Okay. Current can be measured accurately, and hence it is forming one of the 7 basic units. So this is the amount of the smallest unit of charge, and you can see how little it is. Okay, but then don't get fooled by my 10 raised to the power minus 19. The fact is this is not small. Charge of electron is not small. 1 Coulomb is very, very high charge. Very high charge. Okay. So just to tell you how high this 1 Coulomb charge is, in your lifetime also, you will never be able to see 1 Coulomb of charge isolated anywhere. Okay. So if there, just to give you one more example, if 1 Coulomb of charge is here and 1 Coulomb of charge is kept there, and the distance between them is 1 meters. The distance between them is 1 meters. The kind of force of repulsion that we are talking about is 9 into 10 raised to the power 9 newtons. Okay. So this is the kind of force we are talking about. So which is enormous amount of force. Okay. So if you see 1 Coulomb of charge, placed somewhere, first of all, it is not possible. If somehow it is there, just run away from there because it can attract the neutral objects as well. So this is an enormous amount of force that gets generated. Fine. So this is not small. Charge of electron is not small. 1 Coulomb is large. Okay. So practically, we will be dealing in the numerical charges of nano Coulomb. Nano is 10 to the power minus 9, or micro Coulomb. Okay. So things like that. So just, Acha, by the way, till where your school has done this chapter? Till what topic?
So we finished the first chapter.
What?
I think the last thing that we did was Gauss's law.
Yeah, that's all. Like that was the first chapter. I think that's what's electrostatics in our textbook.
So we have done with the first chapter in school.
Yeah.
Oh.
They started in 11th grade itself, like before our 11th finals.
That's quick. Okay.
Yeah.
So now that your school is closed and some of the schools haven't yet started, so that's all for now, right now. Okay. So, all right, Karthik, which school you go to? Okay. Fine. And who else is new today? Shriram, which school you go to?
Sir, that's Chaitanya only. That's, I think he's using his
Sir,
dad's laptop.
sir, Chaitanya. I'm Chaitanya. I'm using my dad's laptop. My laptop just messed up.
Okay. Fine. Okay, everybody else is same. This 232, 289, I don't know who is this. Yes. Okay, so let's do a quick numerical, which you might have already done in your textbook, but just as a part of the practice, we start with the basic numericals, and then we'll go to the higher level. Okay, so suppose you are accumulating 10 to the power 9 electrons every second. You accumulate this much electrons. Okay, so how much time it will take to create 1 coulomb? You accumulate 10 to the power 9 electrons every second. How much time it will take for you to create 1 coulomb of charge? Okay. Remember, 1 year is roughly equal to pi into 10 to the power 7 seconds. This will help.
Approximately 200 years.
I got 6.25 into 10 power 9 seconds. So
Approximately 200 years, sir.
yeah, approximately 200 years, correct.
Approximately 200 years.
Yeah.
Okay, so you are accumulating 10 to the power 9 electrons. So how much charge you are accumulating every second? 10 to the power 9 into charge of 1 electron.
So
Right?
1.6 into 10 power minus 10.
So this is the charge you are accumulating per second.
Per second.
That into time is equal to 1 coulomb. So from here you'll get T is equal to 6.2 something. Yeah,
Yeah,
into
6.25 into 10 power 10.
Part 9.
9.
9, sorry, yeah. 9.
9 second. 1 year is pi into 10 to the power 7. So roughly you'll get this divided by pi into 10 to the power 7 will give you around 198 years. Okay. So we are talking about 200 years to accumulate 1 coulomb, even though we are accumulating 1 billion electrons every second. Okay. So that gives you another indication of how big the 1 coulomb charge is. Okay. But at the same time, let's do this small numerical and we'll discuss something which is amazing about charge. Suppose you have a cup. This cup can store 100 grams of water. Let's say this cup has 100 grams of water in it. Okay. So you need to tell me how much is the positive charge inside this cup of water. Okay. How much is the positive charge and negative charge? Of course, total charge is 0 because same amount of positive and negative charges are there in. But I'm asking you, what is that positive charge which is equal to the negative charge? Water in it, 100 grams of water.
So can we use a calculator?
No.
Oh, okay.
It is not allowed anywhere. Right?
So do we have to express it in Coulomb?
Coulombs.
Or,
How many coulombs?
So is it 8.8 into 10 power minus 19?
Coulomb.
Yeah.
That is less than the charge of no, that is around 8 times the charge of electron. So you're saying that only 8 electrons are there inside 100 gram water.
Okay. Oh,
So is it approximately 4.8 into 10 power 6?
Yeah, I was looking at something like that. Okay. Any other answer?
Sir, I
Getting
got
8.88.
approximately.
Tell me.
Sir, I got approximately 5.28 into 10 power 5.
Why people are getting different answers? It's all about calculation, right? Okay. So 2 or 3 students have got 5 into 10 power 6. All right, so listen here, all of you. First, I need to find out how many water molecules are there inside this cup of water. Okay, how will you get that? It has 100 divided by molecular weight of water is 18. This much moles of water is there, right? 1 mole has how many molecules? 6.023 into 10 to the power 23. So this multiplied by number of moles will give you number of water molecules, yes or no? So this is the number of water molecules, and every water molecule has how many electrons? Here, plus. Somebody was saying?
10.
10. Hydrogen has 1 each, oxygen has 8. So 10 electrons, 1 molecule of water has. So these are the number of molecules, that into 10. So this will give me number of electrons that are there. Okay, number of electrons into charge of 1 electron. This is the total charge of the electrons. This is the amount of negative charge inside it. This is equal to roughly 5 into 10 raised to the power 6 Coulomb. Okay, we just discussed that 1 Coulomb is huge amount of charge, but here is the nature is giving us 5 million coulombs inside just 100-gram cup of water. Okay, but we as humans are incapable to isolate even 1 millicoulomb from 5 million coulombs from a simple cup of water. Okay, so even though it exists in a neutral form. Okay, so this is something which I wanted to demonstrate here, and it is there in your textbook as well, so that you can appreciate these facts. Okay, now we have discussed so much about the charges. Now we can discuss formally about the properties of charges. Okay, so we'll list down some properties of charges. By now you might have understood that this chapter is much easier than those 11th topics. Anyways, properties of charges. What could be the first property? I mean, there is no first, second, third. What could be one property? Can you tell me?
Like charges repel.
Right. So you're talking about the how two charges will behave with each other, right? That is the property of, it is not a property of an isolated charge. Okay. It is the behavior of two charges, how they behave to each other.
So
But
they're
yeah,
always added.
that could be said as well.
So charges are always added.
So they're
Charge,
conserved.
yeah, charge can never be created or destroyed. They can only
Correct.
be conserved.
Correct. So please write down conservation of charge. Let me tell you, these laws or these properties are very simple, but you will find it most difficult to apply in numerical. I'll demonstrate it when we'll solve the numericals. Conservation of charge. The statement is very similar to conservation of energy. Charges can neither be created nor can be destroyed. Okay, it can just move from one object to the other object. Fine. So for isolated system, the statement is, for an isolated system, charges will be conserved, or the sum of charge will be a constant. Okay, it's like conservation of energy, conservation of momentum. Anything that conserves remains same, a constant. Okay, so for example, if this object has Q1 charge, okay, that object has Q2 charge, okay, and if I connect a wire, they will exchange the charge. So Q1 will become Q1 dash, Q2 will become Q2 dash. But if you say that this is my system consists of both the charges, is your system isolated from surrounding? Can I say that is true? Yes or no? What does isolated system mean?
So there's no
external
interference.
change. Yeah.
See, isolation means many things. Okay. So with respect to the charge, isolated system means that it cannot exchange charge from outside. Simple. Okay, please write down. Isolated system implies that the system cannot exchange charge from outside. Okay, so can I say Q1 and Q2 together are isolated system? They are not connected with anything outside, right? So charges are conserved. So whatever was the sum of the charges before you connect the wire should be equal to the sum of the charges after you connect the wire. This is the conservation of charge. Okay. What could be the next property?
The charges are always added.
The additivity of the charges. Please write down additivity. Okay. Additivity in your textbook is the first property, but it is fine. We can move it up or down. So additivity of the charges simply says that if you have a system, you add Q1 charge and then you add Q2 charge. Total charge will be how much?
Q1 plus Q2.
Q1 plus Q2.
It has initial charge of Q0. So Q0 plus Q1 plus Q2. So they'll just get added up. Fine. But then if I'm adding minus Q, okay, instead of adding plus Q, if I add minus Q, total charge will be Q0 plus Q1 minus Q2. So they add or subtract like numbers. Okay, and that's the reason why charge is a scalar quantity. It doesn't have a direction. It doesn't follow any vector law of addition or things like that. It's simply a number which can be positive as well as negative. It's a scalar quantity. This is the demonstration of that fact. Okay. Next is, what is the next
Charge
thing?
can be a quantized, it's a quantized quantity.
The quantized quantity. Please write down quantization of charge. Now, what does it actually mean? Technically, we have said it is quantized, but like whatever we have discussed till now, what does it imply?
So like you
So
can't have
it's
something like 1.5 charges or something. It has to be like a whole number.
yeah, it has to be a whole multiple of the charge of one electron.
So if there is a charge that exists in nature, can I say it should be an integer type the charge of integer times the charge of an electron?
Yeah.
If Q is a charge anywhere in the universe, can I say Q is
Any.
some integer times the charge of electron? N has to be integer.
Yes, sir.
Does it make sense? Why it makes sense?
So because electron is fundamental unit of charge.
Right. So electrons, you can't divide the electron charges further. So there can be the minimum amount of charge is 1 electron. Next possible charge is 2 times the electron charge. After that, 3 times the charge of electron. 2.5 times charge of electron doesn't exist. So they vary in integer times. I hope all of you are getting it. So n should be an integer. This is the quantization of charge. So it is not a, let's say, continuous variable. It's a discrete variable, which varies like E, then 2E, then 3E, then 4E, 5E, plus minus both sides. There is nothing between E and 2E or 2E and 3E. Okay, fine. But in reality, charge of an electron is so little. The difference between E and 2 is almost zero, nothing. So the jump between the adjacent and the next possible charge is this much only. Okay, so it doesn't matter, even though it is discrete or charge is quantized, you can still use the integral and limits or whatever calculus you want to use, you can use it. Usually you can't integrate a discrete variable, okay, because it has to be continuously distributed thing. If it is a discrete variable, you have to individually add it up. But the difference between the adjacent and the next charge is so little that you assume charge to be a continuous quantity. Is it all of you clear with all these 3 properties? Any doubts?
Yes, sir.
Okay. Fine. So please write down charging. See, when I teach electrostatics, I go back and forth. So sometimes I don't follow the sequence given in the book. Okay. So sometimes whatever is given at the end, I'll take it up the first, like that it will change. So charging is what? What do you think charging is?
Inducing charges in a body, like.
So is it like storing up electrons in one place?
Correct. So all of you are correct. But formally we say process of, it's a process, it's a verb. Process of creating, not create. Creating is a wrong word because charges cannot be created, right? So you have to be careful. Process of generating. and isolated charge. Is charging. Okay, so typically there are three ways in which charging is possible. Okay, and we have discussed the most primitive way of creating charge, which is using friction, right? So the first way is that, so you have three different ways of creating charges. We'll discuss that. The first one, friction. Please write down. What do you think the second one?
Induction.
Correct. Induction is there. What the third one?
Induction, I think. Yeah.
By conduction. Okay. Now, friction is a random phenomena. Charging by friction is a random phenomena. You can create the charge, but how much charge and how you can control, nobody knows properly. Okay, so it is a futile effort to understand charging by friction systematically, because it's a random process. So we are not going to discuss it any further. Okay, conduction is movement of charge from one place to the other, and mostly in a metallic conductor or in a wire. Okay, so conduction we are going to discuss in current electricity chapter. So this is parked for the later. Okay, whereas induction is something that we'll discuss right now, and we'll take couple of examples of charging by induction. So this is in your curriculum also, and sometimes in your school exams as well, they ask about the charging by induction. By the way, you had any planned UTs before your summer vacation started? Or it was anyway after summer vacation?
After, I think, like a week after.
So they plan on doing one UT math before holidays, and then after it reopens, they'll do the rest of the UT.
That is
Oh,
for
wasn't all of it after?
Yeah, I think all of it
It was
after.
supposed to be math before the thing, but it doesn't matter now.
Yeah,
And
like
what
according to the schedule, it was like all of them started 1 week later. I don't know.
And what is what is the schedule of summer vacation starting date?
So it started today, and they said it's going to end at May 11th.
That is like what was the planned thing?
April 9th to May 28th.
April 9th. Today is May 13th.
Yeah, UT1 it says would start on June 1st.
Yeah, so like 3-4 days after. It was
In JSS, what is the scenario? Rahul?
so the Karthik is in JSS. I mean, NPS.
Oh, you're in NPS. Sorry. I'm a little bad in remembering associating names. Karthik is from JSS. Okay. It was not school hasn't started yet. Anyways, so we'll discuss the induction now. We'll take two examples. They never made dates clear. Okay. Anyways, so let's take example of charging by induction, all of you. So before we take example of charging by induction, let's discuss a little bit about how metals behave, okay, and how metals are different from the insulators. Then charging by induction will be understood in a much better way, okay. So what do you think, conductor or metal, how it is different from a non-metal or insulator? What is special about the metal?
So free electrons.
Free electrons. It has free electrons. How many? All of them.
No, like
The
free in the valence
outermost
shell.
electron. The outermost electrons are mostly free.
So you can count them.
Per atom, yeah.
Okay, so even though you can count them, the assumption in this chapter is they're infinite. Okay, so it will never end. Fine. So don't start counting. We are going to assume that metal, however small or big it is, has infinite supply of free electrons. But what is free electron? Why it is called free? What is this free mean?
Free to move around, like get move from one place to another, get exchanged between two metal surfaces.
Right. So free electron means that they are not rigidly affixed to a particular nucleus. So they can just move around one nucleus, then they can jump to the another one, then to the other one. Like this, they just roam around, changing the nucleus itself. Okay. So they are just floating as if there's a gravity-free space around, and their motion is random until unless you apply an external force with a battery, which is called electromotive force. Once you apply an external force to a person that is floating in a gravity-free space, it automatically starts moving in the direction of force. Same thing happens here as well. So once a free electron experiences a force, it is free to move as long as it is inside the metal. But of course, it cannot come out of metal. So max it can do is that it can go to the surface of the metal. Fine. So this is how metals behave, okay, or the free electrons behave. Whereas the non-metals or non-conductor insulators, the electrons are rigidly, fixed to a particular nucleus. The electrons cannot leave the nucleus. Okay, so that is a difference between insulator and metal. Now let's come back to the induction. So charging by induction can be done many ways. Okay, there is no limit. There are infinite ways you can generate charge by induction. In our syllabus, we have 2 experiments to demonstrate. So let's take one experiment at a time. So you will take a metallic ball. There is a metallic ball which has a stand. This stand should be insulated. And this is metal. Okay. Now you have another metal ball which is touching the first one. Please draw this. Both the metal balls are similar. Okay. If I bring a positive charge, let's say I'm bring a positive glass rod here, what will happen?
So both balls will have negative charge on the left side and positive charge on the right side.
Okay. Please write down one small thing, that like charges try to come as close as possible. Like charges tries to come as close as possible. Sorry, unlike charges tries to come as close as possible, whereas like charges try to move as far as possible. Okay. So what will happen, like what you have said, there will be free electrons will come near this. Okay. And from where these free electrons will come? Starting, it will come from this end. Okay. So this end will be positive initially. And then what will happen is that positive charges have got a path to go there. okay? Because these two metallic spheres are in contact. So positive charges will try to go as far as possible. So positive charges will appear here, like that. Understood? Any doubts? No. Suppose the second metallic sphere was not there. Suppose this was there, then positive charge would have been here. Okay. And suppose a second metallic sphere was not touching the first one and it was kept like this, then what will be the difference? Now what will happen? Will it remain like this, or there will be some charge separation here as well?
It will accumulate negative charges
Yeah,
on
negative,
the left
negative
side.
on left, yeah.
Positive here and positive there. Okay. And then when you make a contact between these two, the positive will meet the negative and it will get neutralized. So that way you can think. So these will get neutralized and this is the scenario. Okay. Now, if you remove this, what will happen?
Evenly
So
get distributed.
positive. No, they'll
Would
just
neutralize each other.
each other. Yeah.
Will they neutralize each other?
Yes, sir.
Yes, sir.
Reason?
Differently charged and they're in contact. So
There is a path. There's a path which negative and positive charge can come and meet each other and become neutral. Okay. Suppose before taking the positive charge out from here, you disconnect. You disconnect this. Okay. And then you take this away. Now what will happen?
So then evenly it'll get distributed in each sphere. Like negative in the first and then
But
positive
they
in the
can't
second.
neutralize. They'll have separate charges.
Yeah.
Yeah, but it won't be evenly, right? In the
one
first
sphere will be
sphere, there'll
negative
be
and the
more
other will be
negative
positive.
on the right side, and on the second one more positive on the left, because they'll
Will it-
attract each other.
Correct. So will it get
Oh,
evenly
right.
distributed?
Oh, yeah, that's the other case. Sorry.
It won't get
yeah,
evenly
yeah.
distributed. The negative and positive charges will now start coming close to each other. They will not get path, but still what will happen is that they will be like this. They will come closest possible, like that. This is what will happen. Okay. Now, if I remove this, take this to infinity or just throw it away, what will happen?
The negative charge should get evenly distributed.
It'll be evenly distributed.
Why? Why evenly distributed?
So because the electrons can move randomly because of entropy.
Yeah,
Right.
no attraction or repulsion forces are there.
Entropy.
So the other side of the
Like-
sphere is slightly more positive, so we'll go there.
Yeah,
It is not
yeah.
like it is neutral.
But like relative to this, like over here, the electrons would repel each other because the density is higher.
I think there's just no external force of attraction or repulsion now, so just
No,
it will
Drew's
very-
right. They repel each other and
Correct. So
distribute.
they repel each other. Okay. Till now we have ignored the forces among themselves. Okay. So these electrons will repel each other and try to go as far as possible. Because of that, the most efficient way, or due to symmetry, they will distribute evenly like this. They distribute evenly. The only force is among themselves. Okay, so you have generated a net charge by induction. You have induced the charge, but then in order to induce charge, you need to have charge already. So the process of creating charge, it's little bit, there's a fallacy here, but then yeah, if you have a charge, you can create another charge. This is what induction does. Fine. I hope there is no doubt.
So I had a question that's not exactly related to this, but if I had a sphere that was charged, like a metal one, and it's rolling on a neutral metal surface, as it sort of transfers electrons to the surface, would there be any acceleration or like deceleration?
immediately it will get neutralized.
Yeah, it will get neutralized, but does the transfer of electrons affect motion?
Transfer of electron is a momentum transfer also. Electron has a mass. So mass is getting transferred and mass has a velocity. Momentum transfer will generate the force also. Force will create a torque. It will affect the rotation as well. But then why you are getting into all that? It will become a very, very complicated study.
Okay, sir.
So when some object gets negatively charged, it gains electrons. Its mass increases. Okay, it is not just transfer of electrons, it's a transfer of mass also, but the mass is very, very less, 9.1 into 10 to minus 31. Okay, positive charge doesn't mean that protons have come in. It just means that the electrons which were there have left. So the positive charge usually have lesser mass compared to the neutral object. Negative charge will have usually more mass than the neutral object. Okay. All right, so this is the first experiment of creating charge by induction. Let's discuss the second experiment. Okay. In the first experiment, we have used two metallic spheres. Now we are going to use only one metallic sphere. So before we do that, let's discuss something about earthing. Will the mass be noticeably more? No, mass is negligible. Mass is almost negligible. By the time you accumulate so much charge so that the increase of mass become substantial, charge becomes so high that it will create a very large amount of electric field. Thunderstorm will happen and it will get neutralized. It will just break the oxygen and nitrogen molecule, extract electrons from those molecules and get neutralized, or give electrons to them and get neutralized. So you can't accumulate so much charge that mass become noticeably more or less. So we humans are not that capable.
Sir, in charge transfer, is it always instantaneous?
Yes, it is assumed to be an instantaneous process.
Okay.
But yes, at the same time, nothing travels more than the speed of light. But for all practical purposes, we are anyway dealing with electrostatics, charges at rest. While charges are moving, we are not, that doesn't come under electrostatics. We are only discussing what is happening before and after. During the transfer, we are not bothered. Okay, so what I was saying, so before we get into the second example, let's talk about earthing. Have you heard of earthing? Did you get a shock from any electrical instruments, touching electrical instrument?
Yes, sir.
Yes, sir.
The reason is?
You provide a route to Earth.
Yeah, medium for the
Electricity
charges
looks
to
for
travel.
the fastest way to, least resistance way to travel.
What, leaves?
Like it travels on the path where it faces least resistance.
Correct. So it travels in a path where it faces the least resistance. That is the outcome of the earthing. I'm asking you, what is earthing? Please write down. Earthing is a big, thick metallic plate buried inside some ground or field. Okay, so usually every building that is made and every home that is built, there will be a metallic plate or metallic object that is buried. Okay, and this metallic plate will provide a source of, it provides source or sink of electrons. What does it mean? It means that any charged object can get discharged if you connect that object with the this plate. Are you getting what I'm trying to say? There's a plate, okay? This is buried inside the ground, okay? And here is your instrument, your laptop, which is giving you shock. It gives a shock because it has an excess charge, okay? So by some mechanism, if you connect them with wire, before you get a shock, the charge get transferred to it and it will become neutral. Fine. So you may have seen the 3-pin plugs. The topmost is the thickest one, and then you have 2 thin ones there. Okay, the thickest one is connected to the earthing usually. All right. So if there is an excess charge, it will get transferred using the thick this thing to the earth. Is it clear to everyone what is earthing?
Yes, sir.
Okay, so sometimes it is little expensive to put the earthing properly. So what builders do is that they will just provide the wiring like this, but they know that nobody is going to dig the ground and see whether metal plate, big metal plate is there or not. So they'll just say that, see, wire is going, you just buy the flat. Once you buy the flat, you go in, you start getting shocks from the appliances. The reason is the plate is absent. Okay, so it's a very important thing to have at home, because at times you will get a lot of extra charge, and that is the outcome of the lightning. So when lightning happens, okay, suppose this is the house will get electricity from outside only. This is the wire, okay. So suppose lightning strikes this wire, okay, a lot of charge will get transferred instantaneously. So there has to be a mechanism to get rid of that charge. Okay. So at times they put some sharp object at top of the house so that, this sharp object will attract the lightning. Okay. So if lightning is nearby, rather than hitting house, it will hit the sharp object, and the sharp object is connected to the earthing. So all the charge get to the earthing, so your appliances won't get damaged. Okay, so all of those things are very part of any house construction. But anyways, coming back to the thing that earthing provides infinite source or sink of electrons. Source means it can give out a lot of electrons if somebody or some positive charge wants to get discharged. It is a sink of electrons also. So if there is a negative charge object, it can just give away all its electrons to the earthing and get neutralized. Okay, and it's a big plate. Even if it accumulates little bit of charge, it is negligible, and if charge becomes slightly more, it can take some charge from the nearby earth, stones, and all those sand and everything else, and get neutralized. Okay, so now comes earthing by using only one metallic ball. So you have a metallic ball like this. Again, there is an insulated stand. And this is a circuit diagram. You know what does this symbol mean?
That's ground, right?
This is ground. This is also called earthing. Okay. So usually earthing is taken as a reference point of potential. So just like you assume your gravitational potential energy to be zero, any horizontal line, people assume earthing to be zero potential, and they calculate potential difference compared to the earthing only. So when I say 5 volts, 5 volt is compared to the earthing, which is there in the house. If you don't have earthing in the house, get that. It's very important. So coming back. So suppose I bring a positive charge like this. What will happen?
It'll induce a negative charge on the left-hand side.
So many times it will induce negative charge here and positive charge there, right? Okay. Now, if I now remove this, if I remove this, it'll become neutral again, isn't it? But if I don't remove this, if I close a switch, what will happen?
Charges will flow
Nothing.
through the wire.
No, I think it would stay there because of the attraction.
Wait, isn't there like a conducting this thing? So shouldn't some sort of charge flow through?
Okay, yeah.
It should neutralize the positive charges.
So basically what is happening is that this positive charge will hold on to some of the negative charges because of the force of attraction. Okay. And these positive charges are anyway getting repelled and they want to go as far as possible. So they get a path to go to infinity, which is earthing. So these positive charges will just get disappeared. All the positive charges will just leave and go to the earth. Okay. Now, if I remove this, what will happen?
So it'll have permanent negative charge.
Any other
Wait, so
idea?
if you remove what? If you remove the
if I remove this,
so then
only
then the negative charge will get neutralized.
the negative charge will also go to earthing, isn't it?
Yes, sir.
So is the earthing still attached?
Yeah, it's still on.
Yeah,
It's still on.
Okay. Okay.
It will also go. So the trick is, first you detach the earthing, open the switch, okay, and then take this away. When you take that away, the negative charge, whichever is left over, will get evenly distributed like this. So like this earthing arrangement, you can create a net charge by using just a single sphere. Okay. Any doubts till now?
Sir, if I had a sphere that was totally positive and then I connect it to like an earthing setup, can it take electrons from the ground?
Yeah.
Oh, okay.
It will get neutralized immediately. Okay. See, in reality, what is happening is that electrons are moving. Protons are not moving. They are fixed. But for practical purposes, I can treat as if positive charges are moving. Okay. So you can you can treat as if positive charges are moving, which is also the same way as saying electrons are moving in opposite direction. But every time you'll get the correct analysis only, even though you are assuming it as if positive charges are moving. So consider the positive charges motion also when you are analyzing anything. Okay. Anything else?
I have a doubt.
Nothing.
Sir, I have a doubt.
Yeah, you're not audible properly. Come near mic.
1 second.
Somebody is speaking?
So Rajdeep, his mic is a bit weak.
Rajdeep, you can type also.
So now can you hear me?
Tell me.
So nowadays we have even 5-pin plugs also. Like
5-pin plugs?
Yeah, like most of the switches we see 5 pins, right?
That could be the electronic circuit. That is different. That is different. We are talking about electrical circuits.
Okay.
All right. So we have done this much. Let's take a small break and we'll meet after some time. Okay. Let's take 15-20 minutes break. Right now it is 6:36. Okay. So 6:36. We will meet roughly around 6:55. Okay, please take a break, eat something and come back, okay? Bye.
Sir, how do you write on this?
How do I write? I have a writing pad.
Oh, but like when you move the mouse around, you lift the pen off the pad, right? But why does it still move on the screen?
Because screen is 2D in nature. The pen can't come out of the screen. Oh, you're saying that why the cursor is visible? I don't know. That's how it is.
It's probably because of the sense, like when you come close to the screen also sometimes it just shows up.
So lift it up high?
Now it has stopped moving.
Ah, okay.
Come, it moves.
No, I think it's because even the pen works on your finger completing the circuit or something like that. And even if you like hover it above it.
Yeah, it's just I have one of those things like a laptop / tab kind of thing where you have the pen. So when you bring it like slightly close to the screen, like the cursor moves.
Yeah, it moves. It moves.
Yeah.
It moves probably. See, there are 2-3 ways the touchscreen works. There is capacitive, resistive, inductive. So the different technologies are there. Okay, so we'll meet after the break. Okay, bye. Fine. Anyways, you'll also join in. We will discuss now. So before going to the break, we were talking about charging, okay? And we have kind of discussed most of the theoretical aspects of the chapter and had an introduction of charges. Then we discussed properties of charges and how charging can happen, right? Now, the most important thing in physics, whenever we get to know a physical quantity, for example, if I get to know that mass exists, or force exists, or work done exists, or torque exists, what is the first thing that as a physicist anyone should do?
You should mathematically model it, like quantify it.
Quantify it. So if you have a physical quantity and you don't know how to measure it, that physical quantity is beyond your control. You can't do anything with it. Okay. So the discovery of heat energy was practically useless till there was a mechanism to calculate how much is the energy. Okay. So a lot of these discoveries that has happened earlier, for example, magnetism got discovered some around 1500 years back, but it was all useless for first 500 to 800 years because nobody knew how to measure it or what to do about it. So lately only like couple of 100 years back only people have understood that magnetic field is there, magnetic dipoles, how to measure it and so on and so forth. Then only they have built something with it. So same goes with the charge as well. Okay. But unfortunately people have not come out with any proper or any accurate way of measuring charge till now. But then yes, there are efforts and we are going to discuss the most important formal effort that has been made to estimate the charge. Okay, this example that we are going to take, it is not an example of measurement of charge but to just estimate the charge. Estimation of anything just makes you aware about whether it is a bigger charge or smaller charge compared to the other charges. So you can compare the charges using these experiments, but this will not tell you how much is the charge. Okay, so we are talking about electroscope here.
So should we write down all of this or is this just like for extra information?
You have to write down. Why will I give extra information just like that? Okay, to class 12 you have very limited time.
Okay.
I'll not give anything that doesn't make sense. Okay, electroscope. This is also called as Goldleaf Experiment. You have gold foil experiment, now gold leaf experiment. Okay. So let's draw the setup of this experiment first. You have a metallic ball, then a hockey-like structure goes like this. This is a part of electroscope. Please draw this. Everything is metallic. Okay, and it's a single body. All right. And over here, gold is golden, right? So use yellow color. You have gold leaf like this. Okay. So gold leaf. Any idea why it is made up of gold? The gold leaf.
So it's highly malleable, so you
Yeah,
can make a really
malleable.
thin sheet.
Very
So
thin.
it'll be much more responsive to any small charge.
Right. So you can make a very, very thin sheet out of gold. At the same time, gold is very expensive also. So if you have lesser money, you can make a sheet out of aluminum as well. Okay. but usually gold will be the best material. So that's what people are suggesting. So the gold foil is there. It is responsive, as Param said, that it can open up and close easily. So the movement, the rotation should be free. It can open up like a book and close like a book easily. Fine. Now let's understand why it will do so. First of all, I will just isolate my entire experiment like this. I'll put it in a jar. Like that. Why I'm putting it inside a jar?
If your system is if your system is isolated, then you can conserve all the charge.
No, it was isolated earlier also. The air is not conducting anyways. What is the reason for isolation? The reason is gold foil, you have anyway made it very responsive by keeping it as thin. Okay. You don't want you don't want air to flow and affect the movement of the gold leaf. Okay. So you're just making sure that external environment doesn't affect the motion of the leaf. That is what you're trying to do. You're isolating it physically. Electrically, you're not isolating it right now because metallic bob, this thing is after the jar. Okay. So I want to see how much is the charge on this glass rod, which has a positive charge in it. I want to estimate what is the charge in it. So if I bring close to this metal, what will happen? Anyone?
So negative charges will come to the metal bob and the positive charges will rush to the bottom.
Negative charges will come here. Okay. And the entire structure, this metal, the hockey metal along with the leaf, the net charge was how much? Initial
Zero.
net charge. Zero.
Zero.
It should be zero. Finally, also conservation of charge, because I'm not supplying charge from outside. This guy is not touching this. So positive charge should appear somewhere. If negative charge has appeared, equal amount of positive charge, and positive charge will go as far as possible from this external positive charge because of the repulsion. And as far as possible is the gold leaf. And because the symmetry, equal amount of positive, and put yourself on mute. So equal amount of positive charge will get induced here as well as there, the other side as well. Okay. Now tell me, will these positive charges be more if this rod charge will be more?
Yes, sir.
Right? Because then the even stronger negative charge will be here, and that will create a stronger positive charge there. Okay. So that's the reason why amount of positive charge on both of these sides of the leaf will be proportional to whatever charge you're bringing in here. And if positive charge on this side and positive charge on that side, the leaves will repel each other. Okay. So leaves will open up. Okay. So it will be opening up, and the amount of opening, this angle of opening, will correspond to what is the charge on this rod which you have brought in. Okay, so the angle of opening corresponds to the charge. I'm not saying charge is proportional to angle. It could be proportional to 3/2 or 5/2, I don't know, but whatever it is, theta will be more if charge is more. Okay. So this is what will happen. Suppose I bring a negative charge instead of positive charge. I bring negative charge here. What will happen? Then positive charge will be here.
Yeah,
and
the negative
charge will be here. The effect will be similar. Okay, because negative will also repel each other. Okay. Now, instead of I bringing the rod close as given in your textbook, if I touch the rod, if I touch the positive charge with this, by the way, throughout this experiment, you yourself are not touching this positively charged rod. If you touch yourself with your bare hands, if you touch the rod will take electrons from your hand and get neutralized. So you have to be careful. You have to wear gloves and then touch this rod. Okay. So now this positive charge is touching the metal ball here. What will happen?
So the full thing will become positively charged.
Yeah, all the charges will flow through.
So positive charges, what will happen is that it will give out some positive charge. There is a conduction path. It will then travel and some positive charge will appear here and there. So the effect will be same. So you can do the experiment by the induction as well as by the conduction. But if you touch the bulb, you're losing your own charge. You've lost the charges which are there in the rod. So better way, if you want to if you don't want to lose a charge, you just induce a charge, just bring it close. Okay. But as given in a textbook, they're talking about touching it. So that also works both ways. Fine. So this is a small experiment which will help you determine the size of the charge. It will not quantify the charge in any manner. Fine. So this is what is Goldleaf experiment. It is also called Goldleaf Electroscope. Okay. All right. So all the theoretical aspects of the chapter are over now. We are getting into some mathematical aspects of the chapter. Okay. And the first mathematical concept is Coulomb's law. Please write down Coulomb's law. Coulomb's law gives us an expression. Coulomb's law gives us an expression for force between the 2 point charges. It has to be point charge. Otherwise, Coulomb's law is not valid. Okay. For example, if you have a rod which has positive charge like this and a hemisphere which has a negative charge distributed, Coulomb's law will not help you to find out the force between the rod and the hemisphere. Okay. Coulomb's law will just tell you the force between a small positive charge and a small negative charge, or a small negative and a small negative, like that. Fine. So Coulomb's law is not for this scenario. However, you can assume that the big charge is made up of the small charges, and you can take the help of integration and then then you can analyze these kind of scenarios. But Coulomb's law is only for the point charge. And point charge also means this scenario. Suppose you have a hemisphere like that, but charge is just localized only in this small space the charge is. Then this is a point charge. This may not be point mass, but this is a point charge. Okay, so Coulomb's law gives an expression for that scenario. And what is the expression for Coulomb's law? Force is equal to, first write down the expression, 1 by 4
pi epsilon naught.
That into Q1 Q2 by R square. So this will tell you the magnitude. This is the magnitude of the force. Okay, and this is the magnitude of the charge. Q1, Q2 are the magnitude of charge. So if Q1 or Q2 are negative, take the mod of it to determine the magnitude of force. What about direction of force? You know it already. Direction of force is what? No one. It is, write down, along the line joining the 2 point charges. Okay. And there can be 2 directions still. For example, there is a positive charge and negative charge. Line joining between them is this. Okay. So on positive charge, force can be this way or can be that way, because both are along the line joining. So which direction is true here?
On the blue line. On the blue line.
On the blue line, right? So you know that the force will be attractive in nature if you're talking about the opposite sign of the charge. Okay. So knowing only this is enough that it should be along the line joining. Then it will be along 1 if it is an opposite sign of the charge. It will be along 2 if it is the same sign of the charge. Fine. Now there is something which is amazing about this Coulomb's law, which usually people don't talk about. 1 by 4 pi epsilon naught Q1 Q2 by R square. Now Coulombs has derived this expression without calculating charges, without knowing Q1 Q2. He was able to come up with this expression because till now nobody has able to measure charges. So how come Coulomb has come up with something which is so accurate that people have tested this at the atomic level also? This equation holds good. Okay, so this is something amazing, and the way the Coulomb has arrived at this expression is again a sign of a genius, which it is something like this. What Coulomb has done, he's taken multiple metallic spheres which are similar. Okay, suppose you have 5-6 metallic spheres like that. Okay, you have kept them very far to each other. Okay, now suppose you have somehow generated using friction or induction or whatever it is, you have generated a charge Q here. You don't know how much it is. Okay, now if I touch this charge Q with another similar sphere, how the charges will distribute? How much charge will be there and here or there?
Q by 2, Q by 2.
Q by 2, Q by 2, they will equally distribute. Both the spheres are similar, right? So now you have 2 charges, Q by 2 and Q by 2. You do not know what is Q, but what you know is both the charges are equal. Okay, so what you can do is that you can keep these two charges at different distances. First 1 centimeter, then 2 centimeter, like this. You keep on changing the distance, and then you have kept the charges constant, right? So what happens is your expression for force is will come out like this. You draw the diagram with force and distance r. Okay, when you plot it, you'll get a curve like that. And if you best fit curve, if you determine, the variation that comes out is 1 by r square. Using this Coulomb, using the graph, I mean, it will not be, of course, as simple as what we are discussing here, but something like this. He has come out with the law that force is 1 by r square, proportional to 1 by r square, like this, graphically itself, without knowing what is a charge. And then if I touch, you keep this sphere away and touch an uncharged sphere to the second one. What will happen now? How much charge will be here or there?
Q by 4.
Q by 4.
Q by 4, Q by 4.
Correct. So now you can generate Q by 2, you can generate Q by 4, you can also generate like this Q by 8, you can generate Q by 16, and so on. So you don't know what is Q, but this charge is 2 times of that. This is 4 times of this, that is 8 times of that. Okay, so now you can determine the forces among these two. Let me put you on mute. So you can determine between these two, then between these two. Keep distance constant now. Okay, then you can determine, I mean, just randomly you can take any two, and by knowing the force among these charges, which are double, 4 times or 8 times or 6 times, you'll understand that force is proportional to the multiplication of the two charges. Okay, so like this, he has come up with an expression that force is proportional to multiplication of the two charges. Ruchir, what it is?
So how could he measure the force though, sir?
There are various ways. There is a torsional way of measuring force. People have found out the gravitational constant using torsional method. So it's you have things like this hanging, and then there is, the amount of rotation this thing makes depends on the torque that gets generated. You bring a positive charge here, there, and it will attract and create a torque. So let's not get into something which is beyond the curriculum also, but then yes, there are a lot of ways to measure the force. So torsional method is a very sensitive method of measuring force. You can measure the smallest possible force also. So this rod that is connected to the center, it has some constant C. It can create a counter torque which is equal to constant times angle of rotation. So this will resist the rotation and charge will create the rotation. So once they are equal, so the force times the distance, F into L is C into theta, the rotation stops and you can measure the value of F. So, just assume that they have measured the force like that. Okay.
So how did he find the constant though? Like how could he get 1 by 4 pi epsilon?
I'm coming
if he
to
didn't
that.
know the charge.
I'm coming to that. Right now I'm discussing force is proportional to 1 by r square and force is proportional to Q1, Q2. Is this thing clear?
Yes, sir.
Okay.
Yes, sir.
So now combining these two, Coulomb has proposed that force is equal to some constant times Q1, Q2 by r square. And by doing few more experiments, he found out that the value of constant is 9 into 10 raised to the power 9 SI units. Okay. So till now, epsilon naught was not coming in the picture. And then the EM wave theory came up, Maxwell and everybody came. And with the wave theory, there are some properties of the medium that came up. Properties of the medium will have electrical property and magnetic property. Electrical property is determined by a constant epsilon naught. This is permittivity of the medium. This just a name, permittivity. Okay. Magnetic property is determined by the expression mu naught. This is called permeability of the medium. So permittivity and permittivity is how much medium permits the electric field. Permeability is how much the medium permits the magnetic field inside the medium. So uh, these constant came out from the wave equations itself. And once you solve the Maxwell's equation, you will also know that refractive index can also be written in terms of epsilon naught and mu naught, because ultimately light is an EM wave only, and these electrical and magnetic property will only determine the refractive index. So all that is the part of the EM wave chapter. So right now, only thing that we need to know is that the constant was found to be, it is good to associate this expression with something which is coming out from the wave equation. So that is the reason why constant was not kept just an isolated standalone constant. It made sense once it is found out that constant is equal to 1 by 4 pi epsilon naught. It made sense to replace constant with this value, 1 by 4 pi epsilon naught. The value remains this only. 1 by 4 pi epsilon naught is 9 into 10 raised to power 9. Okay. If you change the medium, if medium is changed, what will happen? Epsilon naught will change. Epsilon naught will become some constant times epsilon naught. Okay. For example, inside water, epsilon naught will become 8 times epsilon naught. So permittivity of water is 8 times the permittivity of the air. Fine. So the value of the force, now you have to see here that the expression for the force, which was equal to 1 by 4 pi epsilon naught Q1 Q2 by R square, if you put the same two charges inside water, what will happen to the force? How much will the force reduce to?
1 by 32 pi epsilon naught.
Earlier the force is F naught, let's say. Now inside water, epsilon naught has become 8 times epsilon naught. So force,
yeah. So 1 by 32 pi epsilon.
F naught by 8.
F naught by 8, yeah.
F naught by 8. So force has reduced by a factor of 8. And that is the reason why all the salts, when they are in air, the force of attraction between Na plus and Cl minus, for example, is very high. You can't take out these Na plus and Cl minus. But as soon as you put it in a different medium like water, the force between Na plus and Cl minus reduces by a factor of 8. So the Na plus and Cl minus come out. Okay. So that is how the medium plays the role between the medium plays a role when it is about the force between the charges. Okay. But when we talk about this chapter, most of the time the medium will be air only, so you don't need to worry about a lot of details coming in. It is just, right now good to know that epsilon naught, the value of epsilon naught is different for different medium. Okay.
So how does the value of epsilon change? Because like if EM waves are not mechanical, then how does changing the medium change anything?
Because the medium will get polarized, and if it is polarized, it will have its own charges, which will have its own vibrations, and they will create its own wave, which will create interference with the incoming wave. A lot of other details are there.
Okay, sir.
So
is that why the speed of light also changes in different mediums?
yeah.
Epsilon naught mu naught changes. Yeah.
That is the reason why speed of light also can be written in terms of 1 root of mu into epsilon of the medium. If mu and epsilon changes, speed of light changes in the medium. So all that is a part of EM wave. Again, not part of this chapter. So we'll not discuss in detail. Fine, so this is about the magnitude and direction we know along the line joining the two charges. Fine. Now, when it comes to school exams, they are fond of asking questions in which some theoretical details are there, which are anyway not used in any problem solving. So we can't skip it just like that, because you have to write the school exams also. So let's discuss that. Write down vector form of Coulomb's law. So vectorially, how to write the Coulomb's law. So there are a lot of 2 to 3 markers that are asked in the school. So you better prepared. Draw this 3D coordinate. Suppose 2 charges are kept in space. One is here, the other one is there. Okay. So 2 charges are placed in space. So I need to find out their location as a vector. So we have position vector R1 for Q1 charge, position vector R2 for Q2 charge. I hope it makes sense to all of you. This is just a representation. Is it clear to all of you? Any problem?
No, sir.
Okay, so the force between Q1, Q2 is 1 by, I want to write it as a vector. So F is a vector now. F vector is 1 by 4 pi epsilon naught Q1, Q2 divided by what? Q1, Q2 by
R12 square, right? Distance between the two charges.
What of R1 minus
Modulus of R1 minus
R1
Yeah,
minus
R1
R2
minus R2.
squared.
R1 minus R2?
Modulus.
Squared.
Yeah, square of the modulus of R1.
See, it should be distance between the two charges. The vector which is connecting the two charges, this vector, I couldn't draw the straight line. This vector. This vector I'm trying to find. This vector, let's say X. Okay. So according to triangle law, R1 plus X is equal to R2. So vector X is equal to R2 minus R1. So let's call it as R21 vector. Fine. So magnitude of R21 is what?
So won't your direction of this vector depend on for which charge you're calculating force?
Yes, of course. So we are
Yeah,
going.
so it'll be F12.
Yeah, we are going to discuss that detail. Anyways, okay. So wait. Hold your horses. So Q1, Q2, by distance between Q1, Q2 is magnitude of this vector or not? Is there any doubt?
No.
So this. Now I want to write F as a vector. So the assumption right now I'm making is Q1, Q2 are same sign. If Q1, Q2 are of same sign, the direction of force on 2 because of 1 will be in which direction? Along R21 only or in other direction?
Along
R21.
Along R2.
Along R21, so it will be repulsive force. It will be like this,
Yeah.
right? So now, how do I write a vector whose magnitude is this, which I am writing here, and direction is along 1 to 2? How do I write the direction here? Multiplied by?
N cap. The unit vector.
Unit
Into
vector?
R21 unit vector.
Yeah,
R21 cap.
R21 unit
R21
vector.
cap.
R21 unit vector is what? R21 vector divided by magnitude of R21. Does it make sense?
Yeah.
Yes, sir.
Yes, sir.
Okay. So F21 vector becomes equal to 1 by 4 pi epsilon naught Q1 Q2 by magnitude of R21 whole cube multiplied by
Square.
R21
One vector.
So square. Oh, okay.
Cube,
You
it's cube.
yes, sorry, sorry.
If you are using unit vector, then yes, square, but I'm using full vector.
Yeah, okay, got it.
Okay. Now, what is the assumption? Q1, Q2 are of same sign. Suppose Q1 is of opposite sign of Q2. Direction of force will be reversed? Yes or no?
Yeah.
It will be along the direction minus R21. Yes or no? R21 is like this. Minus R21 is in opposite direction. So if...
So, but that's already taken care of because positive into
Why
negative
you're
will
talking
be.
ahead of whatever I'm going to.
Sorry.
So if Q1, Q2 are opposite sign, if Q1, Q2 are opposite sign, the force should be in the direction of minus R21, should be in opposite direction of R21. The force has to be attractive like that. And like what Param said, I think, yeah, Param is only. So if Q1, Q2 are of opposite sign, it is automatically taken care of. If you put Q1 as positive and Q2 as negative, Q1 into Q2 will become negative. So minus R21 will come anyways. Are you getting it? So all the scenarios are taken care of when you write it like this. Does it make sense?
Yes, sir.
So even though you have started with an assumption, it comes out as a generic one.
So can you repeat that last part once?
So what I'm saying is that if Q1, Q2 are of opposite sign, multiplication of Q1, Q2 will be negative.
Yeah.
Because of that, the vector minus of that vector will come in. Minus
Yeah.
R21 will come.
Yeah.
Minus R21 is in the opposite direction of R21.
Yeah.
And that is the correct direction of the force now because it
Yeah,
will be
yeah.
attractive force.
Okay, okay.
So vector thing is automatically taken care of if you put the sign of the arc.
Okay.
Okay. Now please write down the problem solving strategy. Okay. It is all good to know vector form of Coulomb's law, but we will hardly use it when we solve problem. Please write down the problem solving. To apply Coulomb's law. It is very important, and I have seen people make a lot of errors. Okay, point number 1, use Coulomb's law to determine magnitude of force only. What does it mean? Even though charges are positive or negative, you keep negative charge also as positive. Just substitute the value of the amount of charge in this expression, get a positive value of the force, even though Q1, Q2 are of opposite sign. Okay. Use this formula. Don't use vector formula. Okay. The direction can be taken care independently. How do you take care of directions independently? you know that if it is a positive charge and there's a negative charge, direction of force has to be like this. Okay, so you don't rely on Coulomb's law to determine the direction. Don't just start putting Q1 as positive, Q2 as negative, you get force as negative. So you say that, okay, fine, in this direction, minus of the force is applied. No, that is not correct. You get some force, mod of that force is along that direction. Are you getting what I'm trying to say?
Yes, sir.
Again, I repeat myself, direction of the force should be taken care of separately. And when you use Coulomb's law, you are only trying to determine the magnitude of the force. Do not substitute the sign of the charges when you are using the Coulomb's law, unless you are forced to use the vector form of it. Okay, fine. So we are good to solve few numericals now. Is there any doubt till whatever we have discussed?
No, sir.
Okay, so we have 20 minutes. We are going to solve only numericals now because I'm also a little bit bored with a lot of theory. No questions, right? Anything you can ask, anything? Nothing. Abhiram has some question. No one? Okay. Good, so let's solve few questions. Suppose you have a plus Q charge. This is a plus Q charge, okay? And you have another charge of magnitude Q by 4, okay? The distance between them, this distance is given as small a. Okay, this is the distance between the two charges. Okay, you need to find out where should you keep a charge of small q so that net force on small q is 0. The force will be from both sides. Have you understood the question? So when I ask that question, have you understood that? Everyone will think like somebody else will answer.
So 2a by 3.
Please solve it. Solve it properly, okay? It may take 1 or 2 minutes.
Two A by 3.
2a by 3.
So 2A by 3 measured taking the center of Q as origin.
Measured from where?
From Q.
From plus Q, it's 2a by 3.
Yes, sir.
Okay.
So 2a by 3 from.
Okay, good. So most of you have got it. I'll just quickly do this one. Suppose the distance is x from here. This distance will be how much?
A minus x.
A minus x.
A minus x. Which direction the force will be on small q?
It will be
Due to plus q by 4, which direction? Right or left?
Towards Q.
Left.
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 The assumption is you are assuming q to be positive.
So left.
It can be negative also. Are you getting it? But it doesn't matter. If it is positive, force due to plus q by 4 this way, and force due to plus q will be that way. If it is negative, direction will be reversed. But anyway, this minus that should be 0, both ways. Now, one more thing. Tell me, X will be greater than A by 2 or more than A by 2? Sorry, less than A by 2.
So it should be less.
The reason is it's a smaller charge. If this force should be equal to that force, then the distance should compensate for the lesser charge. When F1 equals to F2, then the net charge on Q becomes 0. Sorry, net force becomes 0. F1 minus F2 becomes 0. So now F1 is K times Q into Q by 4. Sorry, that is F2. So K into capital Q into small q divided by A minus X the whole square is F1. They should be equal to K times Q
by 4.
4 times
X square.
X square. Okay. So you'll get X is equal to 1 by 2 times A minus X plus minus of that, right?
Yeah.
So 2x is equal to plus minus, let's take first plus A minus X. So X will come out to be A by 3, or you can take minus, which doesn't make, which makes sense actually. X is equal to minus A by 2 plus X by 2, right? If I take minus, so then X will be equal to minus A. What does it mean? X equal to A by 3, all of you understood, right?
Yes, sir.
But what does X equal to minus A means?
Oh, it's at the center, I think.
No, so
no, it's
minus A means that it's A to the right of Q by 4.
Yeah.
Right. So you can keep
Yeah,
it
okay.
here as well.
Correct.
Getting it? So X equal to minus A means it is on the other side.
So, but that doesn't make sense, right? Because both of them will be pushing
That's
it.
for when the charges are opposite signs.
Yeah, that's on
Yes, sir.
opposite sides. Yeah.
Which doesn't make sense physically, because both this charge and that charge going to push it. All right. So mathematically it makes sense, but physically it doesn't make sense. So this you have to reject this solution. It has to be between these two. Okay. Note down next one. Draw an equilibrium triangle. Right now I'm taking questions from your NCRT.
So we've done most of these ones.
So
Yeah, I think this one also.
So we have done all this in class already.
So do it again. Soon this time will be over.
So
So the case that
So
we
I got it
rejected,
as
it's only
2A by
if
3.
like
What?
the case that we rejected is only if they say the particle has to be in equilibrium, right? But if they say just force, then we take both cases.
Even
We
at
are
that point, the
solving
force
for
is not
equilibrium
zero.
only. We are solving it for equilibrium.
Oh, okay.
Okay. Now, should I change it a bit? Find out the force on this charge due to these two. Side length is A.
So we have to find the force on one charge due to the other two, right?
Yes.
Is it 4kq square by 3a square?
I'm waiting for others also.
So we have to find it for the bottommost one, right?
It's the same any charge.
Yeah, but yeah, sure. It's just that the direction will be. So it's 3q square by 8 pi epsilon naught a square in the I direction, and minus 3 by 2q square by a square j pi.
Okay.
No, it's minus 3 by 2q square by a square j.
So is it root 3 kq square by a square upwards?
Yeah, I'm sorry, I'm learning how to say it.
Sir, is it root 3kq square by a square upwards?
All right. So have you treated force as a vector here or not?
Yes, sir.
Yes, sir.
Yes.
So you need to take care of the directions as well.
Yeah.
So the force between these two, which direction it will be? The top one and this one?
Bottom.
Along like this? The direction of force, let's say force is F. Between these two, along the line joining with the two charges,
Along,
like that,
Yeah, the side.
right? Both the forces are equal or not?
Yeah.
yes, sir.
So equal, so let's say that force is F.
It's kq square by a square.
What is the angle between these two forces?
60
degrees.
60.
60 degrees. So whenever two vectors are like that, angle between them is 60. How do you get the resultant?
Yeah, a square plus root of a square plus b square plus 2ab cos theta.
Okay, so it will be root over of f square plus
F
f
square.
plus 2 times f square cos of 60,
Oh, yeah, it's f square. So that's
right? 2f1 f2, which is 2f square. This is f square plus f square plus f square, root 3f,
Square.
isn't it?
Yes, sir.
And what is the value of f?
Yes, sir.
Resultant force,
kq by.
it will be k q square, q1, q2 by a
a
square.
square, yeah.
So this is the magnitude of the force. Where is the direction of force?
So it'll be
At an angle of 30
Downwards,
degrees.
yeah, at an angle
Downwards
30 degree
downwards,
downwards. Yeah.
So it will come out like this. It will be along the bicycle. It will be along the diagonal of the parallelogram, right? So right now it is making rhombus because all sides are equal. So
Yeah.
this angle will be 30 degrees. So this is the resultant force like that. Any doubt?
no, sir.
All of you clear, right?
Yes,
Yes,
sir.
sir.
Okay. We'll go to the next. Rahul, keep yourself on mute.
Sorry, sir.
Okay, so let's go slightly beyond school also. You have two positive charges. Okay. Then the distance between the two positive charges, both are q. Distance between them is a. A. Okay. Draw a perpendicular bisector like this. All right. You need to find where should I keep. Where should I keep the third charge? Let's say it is Q. Where should I keep the third charge so that the force on this charge is maximum? Force on capital Q should be maximum. What should be this distance? This one. Y should be equal to what? All of you understood the question, right? Okay, I'm assuming all of you have understood the question. Please solve.
So the sum of the forces on this thing is maximum.
Is that a perpendicular bisector?
Yes. Sum of the forces because of the two small q's on capital Q. When
Is
it will be
maximum.
maximum.
Okay.
So I got to answer as midpoint, like y is 0.
Midpoint, the force will be 0 or not? We just found out. Both the charges will apply equal and opposite force.
Yeah.
There's not maximum there.
Sir, I'm getting it as a by 2 root 2.
Others, please solve. See, in terms of y, you have to get the value of force. Okay. And then you have to maximize that force. You have to probably use calculus over here.
Sir, could you just repeat the question? I disconnected by mistake.
The question is, find out the value of y for which the force on capital Q is maximum.
Okay.
In the given scenario.
Okay. Thank you, sir.
Okay, Mahit has answered. And who else? I think Abhiram has spoken, right?
Yes, sir. I told a by 2 root 2.
Yeah, recognize your voice.
So is it a by 2 root 2?
So it's
Yes,
a by
sir.
2 root 2.
A by 2 root 2.
root 2.
A by 2 root 2. Yeah, that is correct. So I'll solve it now. See, again, this is the concept of the chapters are such that mechanics get mixed with it very, very easily. Okay, so this chapter just introduces a concept of force, but we are still using the Newton laws of motion here to solve the problem. The chapter just tells you what is the value of the force, magnitude of the force, and everything else is mechanics. Okay, so the force will be along that direction because of that Q, and it will be along this direction because of the other. So let's say this is F and that is F. So if this is angle theta, this will be 90 minus theta, right? So total force along the horizontal direction will be how much? horizontally component of force, this force will cancel out that force component horizontally, right?
Cos theta, cos theta.
Does it make sense?
Yes, sir.
Yes, sir.
Summation of force along x-axis is 0.
Will be 0.
F cos theta minus F cos theta. But summation of force along y-axis is not 0. It will be 2F sine theta. Okay. So total force is summation of force along y-axis only, because x-axis is anyway 0. So total force is 2F sine of theta. F is what? Oh, F is Ft. Let me, no, they are different. So F is, let's say this distance is R between the charge and that. So due to symmetry, that is also R. So F will be 2K Q into capital Q divided by R square into sine of theta. This is total force magnitude. Now I will try to write everything in terms of single variable y. I don't want theta or R as a variable. So total force will be equal to 2K, that divided by R square is y square plus A square by 4. This is R square, right? I have introduced y. I have eliminated R variable. Then I have to eliminate theta also. Good thing is sine of theta, y divided by root over y square plus A square by 4. So total force is equal to 2K this into y divided by root over, sorry, not root over, y square plus A square by 4 to the power 3 by 2. All of this is a constant. Is this thing clear? Whatever I have done till now?
Yes, sir.
Okay. So Ft will be maximum when the first derivative of Ft will be 0. Minimum force is anyway 0. Okay. First derivative with respect to that, I mean any variable. Right now the variable is y. So dft by dt, dft by dy, when it becomes 0, you equate it to 0 and then find the value of y. So you can take this as a homework. You have to differentiate. This is a constant, so it will anyway come out of the derivative. Differentiate this expression, numerator and denominator both are there, and equate it to 0. You get some value of y. Okay, and that is your answer. Okay, so this is how you do it. And now just look back at the question, and you'll see that the concept of electrostatics is used only to write the value of force, which is K Q1 Q2 by R square. The rest all is mathematics and mechanics. Fine. So, like I said, class 12th is very easy, but class 11th also get mixed with it. It is very important for you to strengthen your class 11. If not strengthen, at least you should be at some bare minimum level. You can't just completely ignore 11th and hope to do well. Okay, and you will soon see that right now we're introducing electric force. Okay, later on we are going to introduce magnetic force. Then also we'll be doing like this only when it comes to any numerical. Okay, fine. So I think we should stop right now. We have introduced Coulomb's law till now, and from in the next class we are going to introduce electric field, and like the way we have done in gravitation, we are going to find electric field due to various shapes and sizes, rod, then sphere, hemisphere, and all that. And then we'll be discussing the Gauss law. Okay. And at the end of the chapter, there is a discussion on the dipole as well, because isolated charges doesn't exist in nature very freely. All right. But even though isolated charges don't exist, dipoles exist okay, and they are very much part of, and most of the molecules are polar in nature, and there is net dipole moment. So when it comes to next basic thing related to charge that exists in nature is dipole. So we can't ignore dipole. So there is a separate study on the dipole. So that will be done once we finish the study of charge. Okay. So probably we'll take 2 more classes to finish the first chapter. Okay. Fine. So that's it from my side for today. I'll be sending, 1 or 2 worksheets. I may not be able to send many questions because we haven't done much, frankly. So probably from the next class onwards, I can send you many more numericals as such.
So you're gonna send offline homework, right? For now.
Yeah, for now there is be offline. Online will be after the chapter gets over. Okay.
So
Alright,
I had a question.
One minute. So
Yeah.
what I'll do is that I will also soon, maybe in couple of days time, I'll send a form in which I'll ask your email IDs so that I can create your logins. Okay. So some of you might have already got the logins against some test series or some video series or whatever it is. Right now, what I have done probably is that I have removed all your logins. I'm going to create fresh logins. So that's why I'll be circulating maybe a small Google form asking your name and your email ID, or at max your batch, because I'll be going to send the same form to other batches also, and I'll create the logins for you. Okay. Param, you're saying something?
So can you use Gauss's law for the gravitational field also?
Yeah, there is, in fact, but it is an analogy, and Gauss law.
So like instead of Q enclosed, you use mass enclosed.
Yeah, there is, and why it works, because both Coulomb's law and universal gravitational law looks very similar, so it will work there as well. Coulomb's law is valid because of inverse square law. So anything that follows inverse square law, you can draw analogy and get a similar concept there as well. So that's what I said. Whatever you do in whatever you have done in gravitation, all those more or less is similar in the entire electrostatics 1 and 2. So that's the reason why, again, I have taken gravitation in much more detail than what was there in your curriculum last year.
Okay, sir.
All right, then. See you next week. And I don't know whether it will be offline or online. So I hope online session I won't say that it was equally effective, but hope it has, substantially you have learned something. Okay. I understand why force is maximum and dF by dy is 0. See, what will happen is that any function for that matter, it is a mathematical concept. It's not a physics concept. So if there is a continuous function, okay, with respect to a variable, if you plot a graph, it will dip like this. At infinity, the distance becomes so large that the force will become 0. That's that small q. Let me show you that this charge, capital Q, sorry, if it goes to infinity, the R becomes so much high that the force will become 0. And when it is here, the closest, then also force is 0 because forces are equal and opposite. So midway, somewhere there must be some maximum. Okay. So you can plot a graph. It will not be exactly like this. I have put a simplistic graph here. This is at infinity 0 and the closest distance it is 0. So here is maximum. The force is maximum there. And at maximum, a continuous graph, if it makes maximum, the slope of that graph is 0 there. So this line, the tangent, if you draw at the topmost surface, the slope is 0 because it is parallel to the horizontal axis. And slope is derivative of vertical axis with respect to horizontal axis. So df by dy is a slope. At maximum, this should be equal to 0. So that is why it is 0 over here. Now, slope will be 0 for maximum as well as for minimum. So slope will be 0 here as well as there. So we need to be careful at times whether when you take derivative and equate it to 0, you're finding maxima or minima. Okay. So I'm not getting into too much of details because you have in mathematics, luckily right now in class 12th, you have this maxima minima as a part. It's a chapter's name, maxima minima, in class 12. So you're going to learn this concept in much more detail. But unfortunately, it is there in physics before you study in mathematics itself. So that's what we are using here. Fine, Rajdeep?
Yes, sir.
All right, so that's it for today. It was nice to see all of you attended the entire session, even though it is online, and hope you have learned something. Bye for now. We'll meet next week.
Thank you, sir.
Thank you, sir. Bye.
Thank you, sir.
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 Thank you, sir.